So our next presenters represent Red Hat, the developer of highly popular decision management system rules. And Matteo Mortari is one of the most active participants in decision camps in many years. And by the way, today Matteo also is in charge of TCK, Technology Compatibility Kit. And his colleague Daniel, he's new for Decision Camp, but I understand he is an expert in PMML. And together, integration of DMN and PMML is a great combination for trustworthy decision management. And I'm looking forward to their presentation.
Thank you, Jacob. And before we get started, allow me to just say thank you to you, Jacob, and to Sandy for hosting again Decision Camp. It's really great to convene here, even in these quite exceptional times. And I was really looking forward for this event. We are really excited to be here. My name is Matteo Mortari. I'm a software engineer at Red Hat. Today, with my colleague, Daniele, we're going to present this presentation about trustworthy decision management and specifically how explainable and predictive decision making can really help us in order to trust our AI model. So every time that we speak about AI, it's really important to clarify what is the boundary, what is the context that we're speaking of. And in this case, we are not speaking about the doomsday type of AI. So this is what you can see represented on the meme on the left. That is more from science fiction movies. But even as well, if we consider in the context of what is generally called artificial general intelligence, we can take a more scientific or say methodological approach. And if we see even the survey that is represented on the right of the screen, we can see that we are still, even for the most optimistic prediction, really years away conservatively about this type of AI. So what we can speak about today is something more practical and more pragmatic. And this is going to be in the frame of the context of discussion for today. So we are really seeing pragmatic AI, and every time that we will refer to this, we will refer to a set of building blocks, so a set of tools, as the previous conversation was going on. And in this context, we can think about robotics, natural language processing. These are things that are very commonly associated with the AI, but as well nowadays, we cannot really be blind to the machine learning popularity in this area. We don't have to forget as well that digital decisioning, which is say DMN, and all the standards that we've been discussing in decision camps throughout this year are very relevant, as well as mathematical optimization, so how to really have constraint solving problem. Here is where I would like to just very briefly draw back from the previous decision camp, specifically the one 2019 that we had in Bolzano. There we had a very interesting keynote, and it was also reflected in several of the presentations, that one that we did there as Red Hat, but also I clearly remember other presentations from other practitioners and vendors, that we're really thinking about this concept, about a formula for having really this pragmatism to AI in business solution or domain solution nowadays, that combines really machine learning with digital decisioning and mathematical optimization to really have the best tool for the right job. So if we try to bring it to an example, let's think about e-commerce. That is an experience that we have everybody has every day. So I think that it's very common experience that when you get to an e-commerce website, there will be some recommendation of other products that you may want to buy. So this is usually done with machine learning. We can think about clustering. We can think about also other type of machine learning algorithms. But what is the key aspect there is that the e-commerce business can really bring from the data that they have in order to make to you a meaningful suggestion. However, and I think this is also very common, maybe sometimes you have just bought a mobile phone, a smartphone, and you're not really potentially interested to buy a new one already the next month. And this is where maybe those models are falling short nowadays. And this is normally the role of the digital decisioning, or say DMN in this case, where you can and for some policies. For instance, say, if you are about to suggest something that is in a certain price range or above a certain threshold, maybe defer this suggestion because it's not really relevant. And this is where we are bringing the value added from the machine learning to some really human knowledge about this context. And we don't have to forget about the mathematical optimization, such as constraint solving. So this is where really you can maybe optimize for stock and stock levels and really what you can provide depending on the location of your customer. So this is an interesting topic that we explore, and we explore specifically in 2019. We argumented for having open standard to support really bridging from the business automation to the machine learning. So we have done a presentation where we've shown to you how to really integrate this standard, CMMN, but specifically BPMN and DMMN with the PMML standard to really bring together these two words that really have an integration between two main actors here. One is the decision modeler, the subject matter expert, let's say, that develops the decision model. And the other is the data scientist that the role of this person is to produce, thanks to the machine learning process, to give you the predictive model. So here is really where we've shown how these open standards do support this integration, and also starts to help you to open the eye box, or sort of like not try to have the machine learning box, which is normally opaque or a black box, to have it more transparent. We have shown as well a process or a blueprint that the business or domain expert may follow in order to integrate these two aspects together. So on one side, the digital decisioning or decision automation, you would start with your business data that is relevant for a decision model. And then this decision model taking a decision will definitely enact some business action, which in turn will have a feedback loop, say a returning customer. So here is where you can integrate it with the machine learning, and you'll start from the same business data. The key point here is that now you can integrate both structured or unstructured documents, such as images, audio, and the machine learning will produce to you a predictive model. And the key part is to integrate the predictive model with the decision model. And here is really when the two standards both provide you functionality to do it, and is a very effective way to integrate it. But there are really several ways that you can integrate these two standards. So we won't go into the demo that we've shown in 2019, but just as a brief recap, because this will lead then to the stage to Daniele that will continue. So what we have been seeing there is how to integrate case or BPMN process. At a certain point in this BPMN process, we wanted to take a decision that in a first stage was done analytically thanks to decision tables with DMN. And here you have a representation here where the subject matter expert or the business analyst have encoded really that knowledge in the form of decision table. But being the year 2020, so now you can use really the power of the machine learning and really bring from data both structured and unstructured, and really use your preferred framework of choice for machine learning. And this will produce a more accurate in terms of predictive model. So the key point that we argue for is that if you leverage open standards, you can really have them effectively integrated on an open platform. So this was the key aspect of the demo that we did in 2019. Now, with this quick recap, I will hand over to Daniele, because now the important aspect that we want to evaluate together is how we can trust really our predictive model and our business automation solution. So with that, Daniele, up to you.
Thanks, Matteo, for the introduction. So we realized that now we have the possibility to integrate and use different building blocks to use ML together with the traditional decision, together with other let's say, technology. That it's nice, it's powerful, but it could be also, let's say, scary sometimes, or could be have really unexpected behavior. So there are, there are different outcomes that you can get out of a decision service when you're in production, especially if it's based on an ML technology that has been trained on a specific set of data. So some of the outcome could be quite funny. Like, for example, in this use case, there was an AI-powered camera that is supposed to replace the human that moved the camera following the ball in a football game, in a soccer game. And they've never been tested with a ball referee. And there was this error. So as you can see in the GIF, it was funny, the outcome. So people from home were not able to follow the game because of this bug. In this case, the final outcome was, I would say, funny. And okay, people maybe complain because maybe there was a fee to pay. It was like a pay-per-view event and similar. But okay, the outcome, it's clear that it's, I would say, it's a bug. Other cases, the impact could be very, let's say, stronger, and you can have also reputational risk and similar. So this is an article about probably a few years ago when Amazon tried to implement some AI, let's say, processing of the recruiter for a recruiting process to try to unify and maybe simplify the process. And after a while, they realized that the algorithm has a bias against women. And in this case, the outcome is very, let's say, bad from a company perspective, because I mean, as a woman, I can, of course, challenge Amazon because I felt myself as discriminated because of this, or even general reputational risk. So it requires to have maybe a better or an improved way to monitor and understand what's going on. This is not, let's say, the only let's say, reason why you would like to have maybe additional information out of a similar system, because some of those constraints came directly from, let's say, a regulator. So GDPR, for example, has been defined a few years ago and for Europe, but other countries are applying similar, let's say, law about, let's say, what are, how, when, let's say, how and when you can apply AI, and based on that, what does it imply? So he tried to identify very general purpose term, because of course they cannot, it's a very general purpose law, so they are not going to say you cannot use a neural network to do loan approval. But at the same time, they define some, let's say, guidelines or in general constraint, like that you need to provide meaningful information about the logic involved. Or also the fact that the end user has the possibility to ask for an explanation, and at the same time you should be able to challenge the decision. So it's not enough that now the decision maybe is completely automatized by any type of a mechanism, algorithm to say, okay, sorry, this is the outcome, and I cannot do anything. Because of course, I can challenge a human decision, and I should be able to challenge also an automatic decision. So just to try to summarize in general, okay, now I have the possibility to execute my decision service using AI, using ML, using a lot of different technology. At the same time, I need to preserve some aspect. I need to preserve the fact that I need to be able to monitor my system. So I need to make sure that my system, when it's running in production, I can also implement like probes, alerting based on expected or unexpected behavior. So if there is a spike of a decision, a spike of results that are not unexpected, or if I have an expected distributor, because maybe my data are distributed on weekly basis and now is not following the pattern. So monitor, it's a key aspect, because I needed to anticipate if something goes wrong. I need to try to detect it as soon as possible and try to implement, let's say, remediation action, like maybe switch it to a manual decision-making process or adding additional validation. Auditable, at the same time, it's very important, because if user can challenge, I needed to collect the information so that I have all the information about what's going on, all the input that has been provided, when a decision has been applied. So those two aspects, I would say, are even required for traditional decision automation, but here they are probably more enforced, more let's say, I will say, required and must have for similar service. And an additional aspect is about explainability. A traditional decision automation solution usually can have a full tracing. So you can have a step-by-step. It could be very long and maybe not really useful, but you can explicitly say, okay, this decision is the outcome of this step, this additional step, then based on that, I do another step. So you can have the full tracing. But if you have machine learning inside, it's a sort of black box. And even if you're able to provide this intermediate, let's say, tracing, let's assume, for example, for a neural network, given the fact that the network internally are performing some operation, this doesn't imply that you are able to understand what's going on. So, and this explanation, it's even more, I would say, complex because you need to target the right stakeholder. So there are different people involved in a similar situation. There is the case worker that maybe is working directly in front of the customer, so they know exactly how a case-by-case solution should happen. So all the information that I need to fill in my request. So I know exactly what I'm supposed to do, but I don't have, of course, a high-level knowledge domain. So, for example, while a compliant worker maybe knows exactly how the whole process should work, the whole decision. So, if it is imply different step, how maybe the distribution of the decision should be, and at the same time, both of those users usually have, I will say, no technical knowledge. So, the information that we need to provide is to try to explain, to open the black box. It could be very, let's say, domain specific. So, we need to try to make them understand what's going on. On the other hand, we have data scientists that usually is the one that trained the machine learning algorithm behind, that has low or limited domain knowledge, but has a very strong mathematical background. So for them, it could be enough to provide KPI about maybe the distribution, the input score, so the stability of the algorithm and the stability of the model. So the type of information that they're able to consume is different. All those aspects need to be considered, and to finalize I would say the introduction, there was a quite famous presentation from DARPA a few years ago about explainable AI, and they try to envision from an high-level perspective, what an explanation is supposed to be. So if now we have data, we have a function that has been trained, and an outcome that it's sort of black box, like, okay, this is a cat. From a user perspective, from, let's say, an explanation perspective, I would like to have a different type of outcome. So still the outcome, but also information like, okay, I recognize that it's a cat because of the shape of the hair, because of the color of the fur, because of a lot of different information, so that I can be way more confident about the outcome, because it's not just like, okay, that this is the outcome, but I can also understand the reason why this decision has been made. Of course, this is an approach that it's quite theoretical. So this is the desired outcome. So I would like to have an explanation or an explainable model that works in this way. Another aspect, can you, Matteo, move to the
next? Sorry, just my computer froze. Sorry.
Another aspect to consider is that there are a lot of different technology and algorithms can be used to cover this part. And not all of them have the same level of explainability. And this is a sort of property that of the model itself. So it's and explainable AI in general field try to improve the explanation of each of them, but they cannot really make a completely black model fully understandable and vice versa. So there are models that are already interpretable, and explainability maybe just needed to provide a better way to visualize or to navigate the data. So there are two aspects. On one side, we wanted to have some sort of explanation. The other side, part of the problem is related to the algorithm that you select. Let's do some glossary. So explanation could be local or global. So a local explanation means that I take a specific execution and try to explain this specific execution compared to a global explanation that try to describe the general behavior of the model. So trying to understand, for example, if in a local explanation, if this specific decision has been made based on whatever data, while in a global explanation, I can give you an information like this model, it's mainly driven by this feature. This specific aspect is the most important. Then there are other aspects like directly interpretable. So if the explanation is directly consumable, or I need to apply post hoc. Surrogate. So if I can, let's say, transform, let's say, my model in another one that have the same, let's say, the same quality, I will say, of the previous one, but it's more explainable. Then there is the possibility to have a static interpretation or an interactive one, so that in an interactive one, it's like a tool. So this field has a lot of research around, and in general, there are a lot of aspects that you can try to approach. And if you are targeting it not only from a machine learning perspective, but from the decision automation perspective, so that usually have a higher level of abstraction, or in general, a different set of technicality that you can apply, you need to try to cherry pick and understand how these can match with a different stakeholder that we introduce. Let's do an example. So LIME, for example, it's a local explanation algorithm that gives a salience method that try to, so a local explanation. So we try to explain a specific execution and try to score each feature to understand if it had a positive or a negative impact on the actual execution. To do that, we try to, let's say, test the space of solution closer to the input and train a linear model to, let's say, do the split. But apart from the technicality, well, the thing that I would like to highlight about this algorithm is that the final outcome, it's quite, I would say, simple to understand. So it's a chart, so it's a distribution that I can see, so that given a specific input, I can easily understand which feature has a positive impact and a negative one. So even if the model, maybe in this case, let's assume that I have a neural network behind, it's still sort of black box. So I don't know exactly why the model has been trained in this way because of the training data. I know at least that this specific execution, so if, for example, the user is challenging the decision, I know that this decision has been mainly driven, in this case, by number of children that has a positive impact, while age had a negative impact. So this is a way to extract information and provide it to the user in a way that it's easier to understand. A completely different type of explanation, it's more like a sort of interactive tool. So counterfactual explanation aim to provide given an input, so given essentially a set of input and given the actual decision, you can decide that you usually would like, well, let's say one of the most common questions is like, okay, why my loan has been rejected? Why my credit card has not been approved? So I would like to flip the decision. So I would like to change my data, understand how I needed to change my data to have my loan approved. And counterfactual is exactly a system that aims to minimize minimize essentially two costs. They wanted to flip the decision, so you wanted to making sure that now the loan will be approved, but staying closer to your input, because this is an important aspect. Because of course, if I'm asking for a loan and the answer is like, okay, sorry, it's been rejected, but if you have a salary that is 10 times more than now, this will be approved. Okay. It's a nice, let's say, answer, but probably is not what the user is expecting. They would like to minimize the differences, because if I need to provide a new guarantor, I would like to understand how, let's say, the amount of the guarantor that need to cover. So those kind of information, and this algorithm essentially works in a black box way to alter the input and try to learn and try to provide an additional input set of input. In a nutshell, with a diagram, it's easier to demonstrate. So let's assume that the input provided age was 30, and it's below this line that essentially distributed split the space between approved and not approved. 52, it's a completely reasonable answer because it's still approved, but I would like to minimize. So the user know exactly what is the minimum set of changes that need to be done to get the outcome that is expected. And actually, this type of, for example, explanation can be applied even for a completely traditional decision automation solution. So this type of interactive tool that has been mainly designed or let's say been defined to work with ML, in reality, that can be useful also for traditional decision automation, even in a use case where no ML is involved. Because let's assume that we have a quite complex decision logic with multiple decision tables that are nested one by one. Understand what I need to do to obtain the desired outcome. Okay, you can do the analysis. You can do a sort of static analysis to try to, let's say, cover the gap and learn the gaps in the domain. But it's not that straightforward. This tool can also help similar use cases. This was intended to be an introduction to this field. Of course, there are a lot of other aspects. For example, I mentioned the gender bias, so fairness about trying to understand if there is maybe, for example, a geographical bias in the prediction is very important. And interpretability. So as I mentioned, or also in general simplicity of the analysis. As I mentioned, the model selection aspect is very crucial. If you wanted to have I will say, a strong explanation. You cannot cherry pick any type of ML algorithm and expect that they all of them have the same level of explainability. So it's important that based on your domain knowledge, business domain, and based on the level of constraint that you need to satisfy, you can maybe select a different model, a different algorithm that give you the possibility to, of course, solve the issue, so provide the desired outcome, but at the same time preserving the explanation of the result. And of course, it's not one way or the other. It's like a sort of iterative process that you need to do during the modeling of your system. And so it's a quite complex use case. Now I did this, let's say, quite big introduction about more or less the field. Let's see how we can help us providing those capability in the Red Hat offering. So the first component to introduce is Cogito. Cogito, it's the next-gen cloud-native business automation solution that we are creating. So it's intended to solve business automation problems in a cloud-native environment. So leveraging technology like Kubernetes, OpenShift, Quarkus, Kafka, and enabling a lot of use cases that are still requiring business automation and decision automation in terms of capability, but in a different setup. So maybe I wanted to have horizontal scalability. So I don't want to have a big installed worker node that stay there forever, maybe because I know that at a specific hour of my day, I have a peak. So I wanted to be able to scale down and scale up my system based on the workload. Or maybe I wanted to do an event-driven architecture. So my system is going to react based on the event. So I have a lot of events that are coming in. I will make my decision based on that, and I will proceed with making other or triggering processes or similar. And Cogito can help to enable all those use cases. TrustAI, it's an initiative that is part of the Cogito initiative, the Cogito stream that aims to offer value-added services for business automation, targeting those three specific aspects that I mentioned. So providing runtime monitoring capability or advanced runtime monitoring capability, providing the capability for tracing and accountability, so extracting the metric that you need for compliance, and also explanation of the logic involved. From a runtime perspective, Cogito, it's a cloud-native ecosystem, so microservice ecosystem. You have a lot of different services that provide different capability. So you have a core runtime that contains, for example, your decision logic, your DMN, your BPMN, your decision logic, but you have a lot of additional services that provide specific capability, or at least you have other services that may be external downstream or upstream component that provide message, and you need to interact with them. TrustAI, it's part of this ecosystem. So it provides capability that correlate, that connect to the Cogito runtime, the Cogito app, to expose and provide those additional features. In particular, analyzing the model, so analyzing the DML model, it's possible to understand a lot of information that can be used to generate a monitoring dashboard. So for example, I can extract the information that based on the type of the decision, and I can show to the user the distribution in real time about the number of approved loan compared to the number of rejected loan. And this tool can be then used to, for example, implementing some alerting or just do some basic analysis. It's a microservice component, so of course you need also to have operational monitoring. So you need to pay attention about, it's a different type of persona even here, so it's more a DevOps engineer, but Cogito provides those capabilities so that you can understand, for example, if the latency of the response is still under control, because maybe the system is behaving correctly, but is starting to slowing down for any reason, and you wanted to monitor also this aspect. From a tracing perspective, the engine now produces event for every execution so that it's possible to then consume and provide some audit UI so that for every decision, we, let's say, collect all the information related to that decision, and we generate an event, a trace event, and this event then is provided, can be accessed via UI. In this way, the auditor, the compliance worker, can access this UI and see for each execution exactly the data that has been provided and the output that has been provided and the model version that has been used. So it's a way not only to extract the information, but also showing the information. And finally, for the explanation, these include the LIME explanation, that it's an explanation that can target also stakeholder that doesn't have a strong mathematical background. So for each decision, and actually not only for the end-to-end aggregated decision, but for each intermediate decision, you can have these explanations. So you can understand which input has been mainly had the most positive and the most negative impact for the actual decision. Now it's demo time, so I will ask back Matteo to jump in the discussion and show how, and hopefully the demo will work out of the box and see how this can work.
Thank you, Daniele. Indeed, let me start it because I noticed earlier that it was okay. Exactly. So this was just running just before. So just the demonstration. Why do you want to go? Okay, I got it. So sorry that I couldn't start it earlier, but I noticed that it was really bringing Zoom down. So in the case that, because my computer right now is starting to sound like a rocket going to Mars. So in the case that this goes down, Daniele has a backup of the presentation with the screenshots, but hopefully it will manage it for the time of the demo. So to specifically about the demo part, what the use case that we've selected is about a classic use case, I would say. So this is very famous. It's like a kind of like a common, and it's a mortgage approval. So in this case, we will have a customer requesting a pre-approval for a loan, for a mortgage. And then we would like now to move to the next step in this presentation. So indeed, using the theories, the tools, and the actual implementation that Daniele just introduced, now we have the customer that will go to the caseworker and to inquiry about an explanation for why the loan was, we will see in the demo, in a first time rejected. And finally, to understand what will be different constraint, different input, different values, different data. So a different context in which instead the mortgage would have been approved. So to do this, first of all, I will connect I will simulate the microservice that will require the loan. So to do that, I will go here and then here, okay. Okay, perfect. So let's say in a first stage, I'm presenting as the customer. So this first I used this interface to show to you the simulation of what will be happening behind the scene when the customer will use the website. So here is a more of a trimmed down version of the website that would require to input information. So 47-year-old, 4K, monthly salary for a total asset of 250K, requiring 120K, and for a number of 100 installment. As I submit this, I receive back an answer that my mortgage approval, you can see here, is denied. So there is no automatic approval of this mortgage. There are some other interesting indicators here that actually are sub-decisions of the decision model that we will see supporting this, that is about policy compliance and risk score. And so we can get an idea about why these have gone wrong. Seems like the risk score was indeed quite high, and this may explain why, okay, it's in policy, but maybe there is the higher risk score that have denied this loan. So we can drill down now and use the audit API, so localhost, and then I go to 138 for the audit UI. So now we are using, so instead that we move it out, we are no longer in the shoes of the customer, or actually the microservices that the customer has actually invoked. And actually now we are in the shoes of the caseworker that Daniele explained earlier. So we have seen only one request. And if I drill down, in this case, it's very easy to recorrelate. So this, you can see that, okay, here we have already the outcomes that we did expected. So we are providing it through a console interface so that the caseworker can indeed start to see, okay, this is a request, and this is what we have decided. So we can start to see the mortgage approval is false, the risk score, and the policy compliance that I've mentioned earlier. For any reason that the caseworker will need to access the actual original inputs, those are available in the input data. And then the model lookup, it will actually show to you with the editor the model that is supporting this case. So as you can see here, this is a classic decision models, and this is representing the final decision and the sub-decisions along with the risk score that indeed in this case is implemented thanks to the integration of the DMN open standards with the PMML open standards. So now we can go back indeed to the interest of the caseworker who is starting to look at this case and seeing, okay, this risk score seems really high. So it can drill down in the details, and we can see some of the explanation. So in this case, the risk score seems to be due indeed to a number of different factors, and we got them listed here. Now, of course, what I can do is that, I get some ideas that, for instance, age is a relevant factor, as well as the other as well, and as well as the total installment. So here I can get some idea about what I could do or things that I may be able to change in some cases, or that I need to provide some answer. So for instance, our first question, that the caseworker might be in the position that needs to address is like, what if this same person, I mean, the request for the loan was the same, but it was for a person with all the same characteristics, but of different age. So this is something that we can investigate with the counterfactual analysis tool that we've just mentioned earlier. So I want here in this to actually, I'm not interested to determine the sub-decisions, but I'm really interested to see, okay, what does it get me to get for the mortgage approval if I change my age? And I will see I get from the values between 18 and 80. So this will answer the question now, the tool. What I'm trying to do as a caseworker is to say, what if indeed same kind of person, the only difference would have been an age difference. And now the tool is running in the background, and we'll just give it just a few times if it can answer. And this is the usual demo effect, but fortunately I got it with a screenshot as well. So let me see what is it doing behind the scene. Okay. Okay, I'll just give it one more time. Hello, hello. Yeah, okay. It doesn't really want to cooperate. So let me try.
Yeah, maybe your machine is overbooked and she's not really able to handle is not really able to handle the load.
It's really not going well. But okay, let me try just something a little bit different, just for curiosity. So let's say that I'm the same person, and I just want to change from, let's say, okay, I've asked for 120K, but actually I could get away asking different people to help me with the case that I'm asking for the mortgage. I will be happy to say, okay, I'm open for 30K plus or minus for the loan request. So let's see if this is now, it's more happy. But I got, wow, okay. Thankfully, okay, so basically what it's telling me now here is that, yeah, we could actually approve your loan request if only you had the person with the same age, same number of installments, same total asset, and same monthly salary, because this is something that we cannot maybe so easily change. But if you would be happy with just enough, just a little less money to be requested, then you can get it away. Okay, so if I go back here and now I take that information, I could even simulate it. So let's say that I have the same person and I'm checking for 95K. So now, as you can see, I've clicked submit, and what has changed, the microservices have done the same request just for the different number of total required. And now, as we expected, now finally the mortgage approval is through. So if I go here and I go to the audit, then I can see, okay, yes, now this is actually as we expected, but in policy, the risk score, as we can see, it's greatly decreased for this new type of inputs, and the mortgage approval is now true. So we hope that this can really show to you on a pragmatic terms how the different theoretical models for explanation that Daniele introduced, as well as this tool in pragmatic terms, really can support this explanation. And of course, there are really some others models that may be plugged in, and other type of use cases that are sort of like forecasted for this kind of systems. But I hope that this can get you an idea about what you can do when you what is the power when you combine these open standards together and the open platform that we provide to you, that we contribute, how you can really make use of them in a pragmatical use cases. So in the presentation, we will ask Jacob and Sandy to kindly update the slides, because we will have screenshots that actually I think they also refer to a similar case, but just in case to prove it.
No problems. Just
thank you, Jacob. Yes. And we will leave you with a few references that we believe it could be really interesting for you to check out. So that go more into the details about explainable AI and the Trustworthy AI initiative that we are promoting with this presentation. So you will find both videos, documentation, blog articles, and what we can say is really try to get involved in the community. In Red Hat, we are really an open company, and we really engage with the community in the open, not only the one about decision management that Jacob manages, but also as well different other open platform. So please don't hesitate to join, because we really engage with users that comes to us with their own terms, and they trying to find a solution both to the MNC problems, but as well on how to integrate it with machine learning, as I hope that this presentation highlighted to you. And with that, that will be our presentation. Thank you.
Great. Thank you very much, Matteo and Daniele. We have a question from Slack already, and I just remind you that you can either put your questions on Slack and I'll read them out, or if you have a question you want to ask yourself, you can raise your hand on Zoom and I will call on you, and you can unmute yourself and ask the question directly. So Alan Fish had a question, and he did direct it at Daniele, but obviously either of you can address this. But how do you reconcile the user's need for explanation with the supplier's need to protect the intellectual property in their models? And which of the explanation techniques that you talked about give away the least information about the models? Because the supplier or the company could have like their secret sauce baked into that model, and they don't necessarily want everybody to know it.
Well, the main, let's say, persona, or in general, the type of user that we expect that will mainly consume explanation are still an internal type of user. So it's mainly targeting the case worker or people that can help to understand what's going on so that they can provide useful information to the user. But of course, they can open this tool to everyone so they can play around and let's see, for example, I can sort of probe the whole space of solution and see which the minimal age you will be able to get a loan with this bank and similar. But the suggestion is to consider this as an insight set of capability that can be used to enrich your decision logic, and then you can provide information in case of dispute or in case of an explanation, but not to open this as a, let's say, a free open tool for everyone, because yes, of course, it could be, let's say, it's a trade-off between explanation and intellectual property, because
right.
Be able to
well, but I think in the case where there is a dispute, you might have to expose that to, if there was a lawsuit or something like that, it might have to get exposed. So, but that would be in more, more of an edge case, I guess.
Yeah, and especially if you're thinking about the local explanation, it's an explanation strictly related to your input. So you're not really getting any information about the overall distribution of the model. While on the other hand, if you have a global explanation technique in place, yes, it's way more tricky, because give you information like, in general, this model maybe it's mainly driven by age. So if this information could be also sensible for a competitor to maybe understand what's going on. So of course, it's I would say it's not good to expose this tool to end user directly. It's always better to keep these for backend office.
Right, right.
I would like to add one more thing here. It's not only a question of intellectual property, it's also a question of security. What we can see that our customers, big enterprises, they don't want our decision services to return certain information, like even invocation sources or what kind of information was used to come up with decision. Only limited information, because they consider this as an extremely secure information, and certain attributes in your request response should not be shown, not only to end user, but should not even go through network, not to be caught by bad people. So this is when we design decision models, we certainly need some control over what to show and what not to show. So this is a very important question what Alan brings.
So any other questions or comments for Matteo and Daniele? So you can always go over and put your questions on Slack in the 2021 September Slack channel, and if you tag them, then they will get a notification and we'll be able to respond to it.
May I ask you,
afterwards.
because this is really, it was announced about integration of DMN and PMML, and you did not talk a lot about this, or maybe I missed this. Can you just repeat exactly how decision modeling and machine learning used together?
Oh yeah, okay. So let me take this one, Daniele. So that was actually the focus of our presentation at DecisionCamp 2019, and I think as well the recording is online. So basically, what we are showing is that the DMN specific, the short version of it is that DMN has the capabilities out of the specification itself to actually integrate with PMML as one of the open standards that can support for you the definition of a predictive model. And being Red Hat, we try to promote the use of open standard as much as possible. So in the 2019 presentation, you will find the links here to some other video recording, but as well the DecisionCamp 2019. We've shown this integration into action. In today's presentation, when actually shown here, let me try to move out so basically what the same approach we have been using here for the definition of the risk score. So instead of defining the risk score analytically through decision tables, what we did is that we had a data scientist that encoded the risk model as a predictive model. We asked that data scientist that actually used the R to, please persist that predictive model in a PMML open standard format. And then we can integrate it instead of DMN here. So this tool goes to show that really what we demonstrated in 2019 is, so of course, is still valid and is still working, and is the best way that actually you can integrate these two open standards together, thanks to the fact that DMN provides to you the facilities to really integrate this model. Of course, this is not the only way. There are other ways that you integrate predictive models with DMN models. For instance, going through other types of APIs that you may invoke with external services. But for the scope of the presentation, we stick it to use to sort of like, we tried, what we wanted to do also with this presentation is just to have an ongoing conversation from the presentation of DecisionCamp of 2 years ago and today's in a different context about explainable AI.
Can I assume that your PMML model and your DMN model both use the same glossary? They share the same decision variables?
Yeah, in this case, you can see it here. So you can see that in this case, we decided to use some of the input data are going to the risk score. And here we can assume that in these are going to the risk model for PMML invocation. But as well, some other of these input data are used for determining the policy compliance. And this is just a sit-down example. Of course, this can be much more complex and can go direct integration of also importing decision models. You can have a DMN models that invoke another DMN model or fuller subset of data or different data, and then comes back that model, invoke the PMML, and comes back. The possibilities are endless.
Okay, thank you.
Thank you.
Yeah, one thing that I would like to add is about that PMML is a good way because the standard base and you have this sort of out-of-the-box integration. You can even, there are a lot of other ways to expose an ML algorithm that you would like maybe to involve and use. I will say the critical aspect about all this story, about explainability and about in general trustworthy of the model, you need to pay attention of the fact that you need to have a system that can be reproduced. So if you have an external system, maybe, I don't know, your TensorFlow serving component that expose the model, you needed to be sure that if you run again the decision you wanted to reproduce, you want to do some explanation, you are using exactly the same version. And using PMML, this is out of the box because you are bundling the model and the decision logic in a single, let's say, artifact, in a single bundle, and you have this versioning out of the box. Otherwise, you need to pay attention by yourself because if you're running you are invoking external system, it works. There is no technical limitation. At the same time, if you are going to change the model without changing the ML algorithm, without changing the decision, actually you will have a system that you are not able really to understand why the decision has been made because it's based on a specific point in time that now it's no more the case. So this is an aspect to consider when you want to integrate ML and decision automation.
Okay, great.
Okay, we don't have any other questions right now, but if you do have more questions for Matteo and Daniele, just put them on Slack and tag them, and then they can go and respond to them there. So thank you very much to the two of you. We're going to take a short break now, about